Hey everybody, thanks for sticking around and coming out. I know it's been a long day, it's hot, but I appreciate you being here. So I'm going to talk a little bit about a few different topics today. We're going to kind of introduce the lab a little so that maybe I can explain what local first is. You might understand why we're interested in it. We'll talk a little bit about history. We're going to do some live coding because if there's no excitement left at this point in the day, I know you might start drooping off, so you can look forward to that, and then we'll close things out. So we are an independent research lab, industrial research lab, that studies tools for thought. So what are tools for thought, right? The sort of tools for thought movement began in 1945 with this very stylish piece of headgear here. Vannevar Bush, who was the director of the US Office of Strategic Research and Innovation, I think OSDRI, at the end of World War II, imagined before there were computers, I guess there's ENIAC, a kind of science gadget that would be a whole desk and use microfilm. And he's credited with kind of the creation of like thought infrastructure, and he called this thing the Memex. And in fact, some people have tried to build them. This is a JCR Licklider, and that little terminal is one of the first real pieces of hardware built as a user interface deliberately. It was the control terminal for the SAGE system. It was the semi-autonomous ground environment. It was designed to coordinate the US military response in the event of a Soviet air invasion. And actually, this computer was 4 hectares, each of the units. That blockhouse there you see is 4 stories tall. It's absolutely massive. And they built, I think, a dozen of them. I can't remember the exact number. But these were the first time they had this massive investment. But Licklider here, who helped lead this project or was involved in this project, was actually a psychologist by trade. So he went on to write this paper talking about man-computer symbiosis. Gendered language, I know, a little dated today. But he kind of proposed this idea that, even then, this was like 1955, I believe, there was this idea that computers would change the way we lived, would change what was possible for people, and that computers would make us all smarter, more capable, would lead us to great new things. And in fact, that work was picked up by a number of people in the following decades. So the US government had its DARPA program, and that later grew into research labs like Xerox PARC and Bell Labs. You can see here, this is the Xerox PARC Alto, which was the first sort of graphical computer. It ran Smalltalk. Of course, up on the top there, that's Doug Engelbart, famous for the mother of all demos, where he introduced like word processing, video chat, and the mouse, and like numerous other things, all in one like glorious, slightly faked demo. And then also, maybe less known, but still pretty cool, this is Ivan Sutherland underneath, demonstrating the first CAD program. It was called Sketchpad, and it was drawn with an oscilloscope onto that little screen there, and you can see he's using a stylus to actually interact with it. So in fact, arguably, I mean, there are also keys on boards there, but I think it would be reasonable to say that stylus computing is at least almost as old as keyboard-based computing and older than the mouse. And all this work got picked up, right? Famously, Bill Gates and Steve Jobs both went and visited PARC's labs and then, took a lot of notes and went back and built some systems of their own. That's the Mac Plus and Windows 1.1. And then AutoCAD also, which is still around today. All 3 of these systems are still around today. And they have been carrying on that legacy of tools for thought uninterrupted and with no problems ever since. Right, well, maybe not no problems. And in fact, this is sort of why we exist as a research group, which is that increasingly these companies, these groups that once prioritized this work on making computers make us smarter have been taken up by just making computers for everyone. Now, it turns out I am part of everyone, and so is everyone here. And it's great to be able to watch Netflix, and I like to be able to go on social media and find out how I'm dressing wrong or whatever else the cool dance is now. But this is not really going to help me if I want to solve the hard problems of our era. And so classically, Apple was sort of the savior. They were in schools for a long time. But Apple, too, has been a victim of their own success, I would say. And so all of these platforms that were once sort of oriented towards helping people in their sort of creative and intellectual, emotional pursuits have largely been captured by consumer interests. And that's fine, but I don't want to give the impression that no work is going on. For example, who knows what Dynamic Land is? Just Orion from yesterday. So this is Dynamic Land by Brett Victor and a number of collaborators. This is a very special computer. Now, I know that's kind of a surprising claim to make because it looks like a bunch of paper. And if you look closely, you can see there's projectors shining light onto that paper. And what Brett Victor has been trying to find is a different kind of computing which is based in physical space, and I picked this picture deliberately because what you see is a bunch of people using this computer together. And the way Dynamic Land works is that each of these pieces of paper, those dots around the outside, are very special. Cameras above the table see where the paper is, and the computation happens when you put things onto the paper, and you can actually change the way the program works by moving things around on the table, right? And what this creates is this environment where people who are computing are using their whole bodies. You're able to pick something up and gesture at it. You can move things around. You can talk. You can take things away and put them in. And it's a collaborative environment in a way that's totally unique and unlike anything else we've ever seen. And so if you do take one thing from this talk, Dynamic Land would be a good one. This is the Ink and Switch team, or some part of it. We're sort of a rotating group of pirates. From our recent summit, you've got, we all live at home, wherever that is around the world for us, and so we try to get together every once in a while, and you can see folks doing computer science-y things, and that's Todd, our designer, and the usual photographer for when we get together, so that's why he's behind the camera. We're still trying to work on these same problems that go back through Alan Kay and all these kinds of guys. So you might be wondering, so what? Who cares? Why is this worthwhile? Who needs it, right? And we feel that as researchers, the people who we can help, the people who need help, are scientists. This is John Conway, surrounded by tools for thought. These are mostly physical tools for thought. He's built models of various geometric shapes. He does have a computer in the room. It looks like a Sun Microsystems workstation. And of course, the thousands of years old piles of paper. I imagine they were Egyptian scholars with lots of papyrus piled around them. We talked to a lot of writers and journalists. Journalists are very ill-served by the technology world we have today. Turns out that Google Docs doesn't really work in the field, and very often the CMSs that journalism companies build for their journalists to work in are not well suited to the task of journalism. And just more generally, we think of our audience as anybody who makes things, who uses their mind as part of their sort of process, sort of tool users, generally people who build things and so on. And so our research kind of has sprawled out over time into kind of 4 focus areas. And we're going to mostly talk about local first software today, which is the idea that, after talking to these people, what we found was that the cloud really often served them very poorly, right? And so what would happen is, if you're writing a book that takes 10 years to write and you adopt some cloud product, it's probably not going to be there by the end of the book. And if you're lucky, you'll get a little warning before you get that incredible journey email. But if you're unlucky, you might just end up with a handful of JSON, or you go back to open your notes and the iOS update has broken the app permanently. And so this is all about trying to move computing to the device, to the user. And this has led us into really interesting places. But we'll talk really briefly. We also look at what we call malleable software, the idea that as a person who uses a computer, you should have agency over how it works. We follow up on this programmable ink thing, the idea being something along the lines of what if programming had grown out of the pen instead of growing out of the typewriter? And we look at this sort of idea of universal version control, which is if you mess up my Google Doc, why can't I go back? And why can't I have a branch of a Google Doc the way I have a branch of my Git repo on my laptop? Why do I have to work with you looking over my shoulder the whole time? And we think that version control, frankly, is bad for all of us developers too, right? I mean, put your hand up if you have ever gotten confused using Git. If your hand is not up, you are lying. Or maybe you don't use Git, that's fair. Maybe you're just a Perforce person, that's fine. OK, so let's talk about local-first software. So this kind of ties into a very old idea that the stonemasons working on the Sagrada Familia could relate to, which is the idea that a craftsperson, whether you are a journalist or a software engineer, that you should own your tools. And it's been really interesting. I have heard different versions of this claim a number of times throughout the different sessions here. It comes up in different ways, but this is not like a hypothetical concern, right? This is not just me yelling at the cloud. These are things that people told us when we went out and started interviewing people. Local first was kind of a thing we stumbled into. We heard people saying, like, there's a gentleman who has an educational site that he's been maintaining for 25 years. And he said that when Google killed Flash, right, or when the browsers all collectively killed Flash, it cost him years of work to rebuild all of these interactive tutorials and things that he'd built over the years on a new framework. And I was like, well, what tools do you use now? He's like, nothing if it's not web standard, and I build everything from my laptop in Emacs. I was like, okay, wow, that's pretty hardcore. If your SaaS app goes away, I used to be an RDO user before I switched to Spotify, and when they shut down, they had like the option to export a zip file with all my playlists in it. I mean, thanks, I guess. I guess I probably still have that somewhere, but like I've never listened to any of those playlists since. And one person we talked to kind of summarized their attitude about this, which was that they didn't use new tools because they expect their work to last longer than any tool that wasn't already around before they started for a while, which is kind of like a stochastic argument about tools, right? If a tool is already old, it will probably stick around. If you've got a new tool, it probably has a high failure rate in terms of like longevity. The other thing about local-first software I want to mention as sort of an argument, is anyone here actually, we didn't have any Australians, did we? But perhaps the folks from India can say whether or not accessing sites in US East 1 there on the East Coast is actually a problem. Certainly I've talked to Australians who have complained that once you start to have a big complicated website, sure, it's only, about 600 milliseconds from East Coast, I guess it depends on the route. Okay, 500 milliseconds from East Coast North America to Australia. But once you start stacking up round trips, that's a lot. Light speed is actually not that fast, right? Your screen can update. Most monitors these days call it 100 hertz. That's 10 milliseconds, right? That's 50 frames just waiting for traffic to get to you. Oh, and if you have to push a button in a website, and that API has to go all the way to North America from Australia and back again, you're talking an entire second, 100 frames of your life just burned. Game developers think entirely in terms of frame budgets. It was something I always found weird when I came back to the web, which is no one thinks about latency or how fast things go. So to kind of summarize this is the humane AI pin. Did people remember this? It was very charming, kind of stupid, right? Big, heavy, clunky thing you put on your shirt. And, but really cool, right? Like you would hold out your hand and it would like laser onto your hand text that was a chat you could have with your AI agent. But the last thing that AI agent said was, first and foremost, thank you for being an early adopter of AI PIN. Blah, blah, blah. We're ready to inform you effective immediately. We're winding down the consumer business as our priorities have shifted. So if you thought that this was going to be a tool that you could rely on, that you could use in your daily life, well, okay, maybe nobody thought this specific tool would be something that would last for a long time. This is a pretty cool gizmo, more than a daily driver, let's say. But still, this was not an inexpensive piece of kit, right? And now it is literally just a paperweight, right? You don't own your tools if they can be taken away from you. And this is increasingly not an academic concern. There are technical reasons why tools are end of life. There are business reasons why tools are end of life. And increasingly, there are political reasons why you might lose access to cloud or internet infrastructure. But I'm not here to just say we want to go back to the old way. We want to keep all these benefits of the cloud and yet somehow bring back some of these benefits of desktop software. And I'll highlight a couple. One is just responsiveness, which is not the same as performance, right? This display here, this is a CPM, I think, is running WordStar 4. This display was much more responsive than the display that you have. And if you measure the time from when you push the key down, like with a high-speed camera, to when the key shows up on your screen in like Google Docs, it is quite a bit longer than the time it took on these old machines. We have tens of thousands of times more power, and yet things are slower. The other thing that I think is really significant is that this is a Super Nintendo cartridge. If you are too young to know what that is, it was a video game console in the 1990s. This was a pretty good game. But this still works. And if you want to go play, what was that game? Overwatch. Blizzard came out with a sequel, Overwatch 2, and they killed the original game entirely. It's gone forever, right? If you are building for the cloud, everything that you put your time and your career into, however you practice your craft, someday will be erased from the internet. You know, in the words of John Yeats, you will be like one whose name is writ in water. I think that it's kind of sad that the people who worked on Overwatch, that their work is now evaporated, whereas you can still play Super Metroid. And in fact, the binary ROM inside of that game is only a few megabytes, so you can put every Super Nintendo game that was ever released onto one micro SD card and carry it around with you. All right, so that's why I think this is important. You know, we're not in the silver bullet business, but let's talk a little bit about the architecture of local first software. So this is the architecture of the cloud currently. And this is actually, I'm going to poke fun at it, but this is a very sensible and pragmatic architecture for a modern cloud application. This comes from like the cloud people. This is the AWS web application hosting in the AWS cloud from 2021. That's 4 years ago. So just imagine twice as many boxes, I guess, for the current version. No, that's probably not true, like 30% more. And this is how I would encourage you to think about what local first architecture might look like. It's self-contained, right? Because it has to run on your computer. You can't sprawl out into 25 microservices and 15 authentication things and so on. You've just got to kind of work within the box. And those little arrows going to other things, right? What we do is we have the program running in the computer, and then those arrows are synchronizing data to other computers opportunistically when they're able, right? So instead of having the UI be a front end that's running locally, and then the actual logic of the app is in some data center in Ashburn, Virginia, USA, it has to all live there, and then you just move data around. So in this sense, it's not that we're getting rid of the cloud, we're just kind of going to a model where like the cloud is more like a warehouse in our neighborhood instead of the owner of everything we do. Okay, so Automerge is our attempt to try and build this, because having, in an earlier life, I worked on cloud infrastructure at Heroku, later part of Salesforce. I recognize that it's all well and good for someone to come up here and tell you about how you could be doing things differently, but not provide any solutions. So we've been trying to build one. This is kind of a quick schematic. I'm not going to spend much time on this because we're actually going to do some live coding in a moment. But I want to give you the vibe first. So up there on the left, sorry, that's the right. Hang on. No, that's the left, OK. Stages. Up there on the left, you can see the UI. And when we click on that check mark in design diagrams, what happens is we don't just mutate the state. Is that the closure person still here? The state is immutable. It grows only like an immutable database. And so what happens is when you do that, we generate a change. And we're going to see these little icons everywhere. And we take that change, and that just says, hey, what did you do? Well, you're going to insert into our task list the title design diagrams. Oh, sorry, this is if you inserted it. I had a different draft of the slide where you were setting it to done. And then it goes into this little box underneath there. That's Automerge, our CRDT, our conflict-free replicated data types. And I promise no LaTeX today. If you want to learn more about CRDTs, the creators of CRDTs, or two of the creators of CRDTs, gave a talk a few years ago here at this conference, and the video is up on YouTube. And then once you get that change, you put that back into this sort of document. Automerge gives you a state object that would be very familiar to any React developer. Who's a React developer here? All right, surprisingly few. I'm sorry, all you backend people. I'm not trying to put you out of work. There's plenty of work to do still, don't worry. And then that comes up back into the app. And so you get this tight little loop, but you notice there's an arrow going off to the side. That is when you sort of synchronize your data to somewhere else. Now, if you were using IRO, maybe you would sync it directly peer-to-peer to somebody. But in our case, we just, oh, there we are. In our case, we send it to a server with a WebSocket connection running on DigitalOcean, I think, coincidentally. And then everybody else can fetch from there, right? So you can see the sort of streams out. And the key thing to notice here is that for everybody else, they don't have to volunteer to do anything, right? They get the same little message saying, hey, something has changed that you do. It's a homogeneous interface whether the data is created locally or remotely. All right, all talk, no action. Let's do some coding. I did a really early version of this demo 3 years ago at this conference. And in that one, I finished the talk on time. So let's all hope we get through it on time today. And here we go. OK, first step, let's get the display up. I'm going to set us to mirroring. OK. Thank you. Oh, geez, no, it's risky to, no, let's not log into anything right now. Thank you. Local first. All right, so here we have, do I need to enhance? Enhance. OK. Is that big enough? Someone, yeah? Anyone in the back? All right, people seem happy. Cool. So this is a really, really simple front-end application written in React. It has no persistence of any kind. It's just a little to-do list, and you can see from the TypeScript types here how it looks. You've got tasks, which is just a title and whether or not it's done, and a list of tasks. That's the task list. And we have, that's it. It's React state. We're going to go away. No. We are going to run it here so you can see what it looks like, and we're going to leave this running as we go. Oh, did I already start it running? Oh, I'm good. OK, cool. So here it is. It says Automerge task list, but it's not actually an Automerge task list yet, because if I say, hi there, JOTB, and then I refresh, it's gone. Well, that's a bummer. Let's turn this into a real-time collaborative app where all the logic lives in the browser, and let's do that with Automerge so you can see how it feels. OK, so venga. The first thing we're going to do is we're going to add Automerge. That part's pretty easy. We just add this library, React, no, not React 3, npm add Automerge React. And what this does is it's just going to add a few dependencies. Now this is available, and so what we're going to say now is in the main part of the application, all of your Automerge is a document store, if you want to think about it like that way, like some other great document stores out there, Couchbase and so on. And so we're going to create one here in the browser. So we're going to import repo from, no, oh, yeah, thank you, very helpful, Automerge React. And we're going to grab like this repo context. This is just React goo. And then to get started, we're going to import this broadcast channel. And so broadcast channel, the browser is crazy powerful now, by the way. Broadcast channel is a message channel. It's like a message bus that's built into every browser and lets you send messages, and every tab that has the same origin will receive them if it's listening. So we're going to send messages over that for our demo, and then we're going to chuck our data in IndexedDB. Cool, we'll save that, and then we're just going to say const repo equals new repo. No, thank you. OK, you're close. We're going to put that in square brackets. Yes, thank you, Copilot. Not as good as, yeah, OK, that, sure. I think that looks right. You know what? We actually don't need this argument here. Thank you. No, stop it. Stop it. It's very persistent here. Cursor was even worse, so I was like, I'll do it in VS Code. All right, and then we'll close that. And then let's console.log repo. OK. And then actually, we're going to pass this. We're going to set up, yeah, thank you. This is better. It's very good at React. These things read a lot of really mediocre React code, and they learn how to write it. And I'm writing some of my own here. OK. So, and then we're going to just set up a context. This will just make the repo available throughout the app. So let's see if it worked. OK, so we've I got to start it. npm dev. All right. Do we have a repo? There it is. Cool. So I'm going to grab the repo, stick it on a variable, and we'll just say temp1.create. Cool. And we made a document. And then so we can say, like, tasks is an empty array. There's that handle. I guess I should say h equals h.doc. Great. So see, it's given us a little document with an empty array of tasks. And what's cool is you have in your debugger here basically like a REPL to your database. And this is very handy when you're trying to debug things. OK, so far so good. All right, now we're going to want to make a document. And I am going to crib for this part because later, this code isn't complicated, but it's annoying to type precisely. So we're going to grab it here. And I'll explain what this little bit here is. This is, we're not writing TypeScript right now. This little bit of code here is going to set the hash in the URL of our web page to the name of the document that we have. And so all Automerge documents are identified by a globally unique name. It's a UUID effectively. And this is just going to either find the one that's in the URL, or it's going to make one if we didn't have one in the URL, and then put it in the URL so I can copy and paste it between windows. Good? And then if it doesn't find one, it's also just going to make me a new empty document with tasks. So let's console.log found a document. Cool. All right, so let's see how that looks. Oh, yeah, there it is. OK. And you can see now, here is our document. I don't have to worry about anybody doing anything with this, because it's not really there yet. And then we can take this and store that, and then temp1.doc. Again, we'll see those tasks. Now, if we click New Task, like magic, nothing has changed. That's because we haven't actually hooked it up yet. So let's hook it up real quick. All right, we're going to take this here. We're going to pass this doc URL equals doc URL handle.url. And then, of course, we haven't actually supported that, so we'll hop over here. We're going to say doc URL. Great. And then this is a branded type, actually. Sumaya was talking about this in her talk about Automerge URL. And this just is handy so you don't accidentally pass in like user input as an Automerge URL. And then the last thing we're going to do is just say const doc set doc. Great. And that is the, no, not use state. Oh, see, it got ahead of me. Use document. And let's import that, please. Great. And that's going to be the doc URL. OK, so what we've done here for folks who don't know React is I've just used a React hook. It's like a very thin front end in front of Automerge that puts us into sort of React land. You see the line underneath there. This is sort of more like ephemeral React style. You have a tasks and set tasks. We have the same thing here. It's doc, and it's actually change doc is more idiomatic. Doesn't really matter what you call it. And so now we have that document. And whenever we ask for the doc, we'll get back the current document. And we can update it by saying change doc and just doing things. So what we're going to say is, like, if we don't have a document, because it hasn't loaded yet, we're just going to return. Yeah, very verbose. Thank you. No, let's close it off here. Thank you. Yeah, so ambitious. And then what we'll say is, if we have a doc, then we'll say, OK, pull the tasks off it, and now they'll be available. So now, if we refresh, OK, we should be able to actually, let's see if this works. temp1.change d.tasks.push done false title make a doc task. How many parens? OK, no. This. Thank you. Hey, and just like that, look, from my command line, this is now done it. But I mean, this isn't local first, this is local only, right? We're just doing it here in this one window. But you know what? We're already actually synchronizing because we set up that broadcast channel. And so if we put this in here, and this is always exciting, hey, it worked. And now, in fact, if we make a new task, oh, right, we haven't hooked that up yet, but let's maybe push another thing into the thing, make a second task. And look, it shows up in both of them. We now have a live collaborative app. It just doesn't have a user interface. So this is going pretty well. All right. OK, so the next thing we're going to do is we want to actually hook this up. And we're going to go a little quick here, just because this is sort of not very exciting to watch somebody hand code, boilerplate. But we are going to just keep that moving. We'll copy and paste the 3 lines of code. Where is it? All right, well, I guess I won't copy and paste 3 lines of code. Oh, there it is. Just didn't have it highlighted. This is going to make new tasks. So we'll just grab that whole on-click. This button, yeah, that looks right. And one thing to note about Automerge is that Automerge is going to take you at your word, which is that if you say that you have if you replace an array, which is actually like sort of idiomatic React style, Automerge will just say like, oh, he's got a whole new array. You know, she doesn't want those old tasks anymore. So we're using sort of mutation-looking syntax here, but it's actually just updating the array. And now when we hit new task, we make the task, and it appears on both. So there we go. Now, I think in the interest of time, the rest of the methods here all look the same. We could do another, but I'm going to keep things moving. And actually, what I'm going to do is I'm going to jump ahead to the same app running on another port. And this is the same code, but I wanted to take a moment and to show you that because we're recording the changes, not only can we synchronize them between the different browsers, and this version just has those other things. This is like the TV magic where we pull the cooked roast out of the oven for a moment here. But on this one, I've also added a scroll bar on the top. And what this scroll bar does is it actually lets me rewind time to earlier states of the document. And so we can even come over here, and you can see that this is all really live, and I can say, hello, Jay on the beach. Isn't that neat? And you can see that the time is actually passing, and this is a scroll bar issue. But there we go. And we can now scroll back and forth through time. And I can even take this URL, and in a new tab, I can open it, and it'll take me right to that point in time. So this would be a lot of work with a conventional API to set up, to design. And every client has access to this history, just like when you check out a Git repo. With a bit more work, more than I can show in a live demo, you could add diff views and highlighting. And in fact, we're going to go and look at that now, because I think that's enough of the live demo. So yeah, let's go back to the slides. OK, whew, that was a lot. So I promised some practical local-first software, and if building toy-size to-do lists doesn't seem practical to you, let's talk a little bit about what we actually do use this for at Ink and Switch. And this started sort of 3 years ago, actually shortly after I was at Jay on the Beach last time, and we were having a conversation at our team gathering, and someone said, hey, what if we made things we could really use? Because prior to that, we made a lot of prototypes, like the one I showed last time, and you know, like Alan Kay and Doug Engelbart built NLS, and they built the Alto, and hundreds of people use these things, and so we thought, you know, like how hard could that be? Pretty hard. And so I had shown this proof of concept, which was so fragile at the time that we couldn't actually use it at all. But it was sort of an illustrative thing of a collaborative, version-controlled type markdown editor. And so now we have it, and we use it every day. And I have personally thousands of documents in my patchwork here. And I'm going to show you a little bit of what patchwork is like with these videos from my colleague Jeffrey. With patchwork, you get sort of version control. And this is not a product pitch. This is just what you can do with Automerge, because we actually haven't released this to anybody yet. And you can, right, on any document in patchwork, you can make branches, you can make forks, all of those things you're used to as a software developer that you don't expect to have in your text, rich text editor. These are available here. And in fact, sorry. Which slide am I on? OK. Not only do these tools work on text, because Automerge, all of this power comes out of the shared underlying sort of JSON-like substrate, you can do the exact same thing here on a TL draw drawing, right? And you can see that this green stuff is being highlighted automatically because it's new on this branch. And so you can actually apply these same tools to lots of different things. And I want to emphasize that like these are synthetic examples, but we really use this stuff every day. And like here is our malleable software essay about this very subject which we're working on. And as part of building this, we've been building all these extra tools to help us build this, to write this piece better, right? We have this power, because it's a local-first application, to extend it and take it in new directions. And you can see here, actually, can I go back to the word count? This really is, oh, no, OK. It really is a pretty big essay. At the moment when we captured this video, we need to edit it down because it's 17,000 words in this thing with the full history, and it loads in about a second. So this is not like hypothetical. This really is the real deal. In fact, it's so the real deal that one of the other tools that one of my collaborators built was a statistical model to predict when his baby would be due in order to decide exactly how many days him and his partner would be comfortable with him staying at our team summit. He left 2 days early. In fact, it's so general that I built this little Minecraft clone based on a Three.js demo, and all I had to do was tell it to load the blocks for the Minecraft world out of an Automerge document, and boom, you get this. And in fact, you have branches and history built into this game, which I don't know it's useful, but it sure is fun. I admit that's not the most practical. And so the result is that we have this system now that's built up on top of this idea of local first software, this malleable software with universal version control, which really is starting to feel more like a kitchen, right? It's a kitchen for your work, where instead of having sort of like the current way we think of software, I would say, is more like a food court or a high street, where if you walk down, you can go anywhere you want, but if you don't like what's on offer, there's nothing you can do about it, right? And in a kitchen, with a few simple tools, you can make anything you want. You can make Japanese food, you can make Spanish food, you can make Italian food, you can even presumably make American food. I don't know if anybody here is into that. But it's not that the food court or the restaurant is worse. It's that a kitchen is different and lets you do more if you're willing to do more work, and sometimes that's what you want. So that was malleable software, and the question we always get about this local first thing is like, well, how do you secure all this? So the other big project we've been working on is this one here, which is Keyhive. It's a local first approach to access control and encrypted collaboration. People building local first apps today are just using cloud authentication. You do whatever you normally do to secure your API before you decide if you're going to send someone data or accept their versions from them. But this Keyhive thing will let us federate that and have sort of access control that travels with the data. And it's very simple. No, I'm not even going to try. I'm kidding. There's going to be a talk about this at Local First Conf in Berlin in a couple weeks. So if you're interested, you can follow up later. But I want to close with a brief sort of meditation on software as craft. Because I think that it wasn't the intent of our work to kind of radically simplify software architecture, but it was a necessary precondition to have simpler software architecture in order to be able to do this kind of work, right? What Orion showed us yesterday, this adversarial interop, it relies on a very thin layer of integration between the user and the actual software, which is running somewhere in the cloud. Whereas with local first, this malleable software thing I just showed was much easier to build because it was really the authentic program running in the device, right? And the original promise of the computer was to be a bicycle for the mind, right? And Jonathan Edwards said, we were promised that, but we got aircraft carriers instead, right? And like an aircraft carrier is a very impressive piece of engineering, right? The cloud systems that you all are building on Kubernetes and massive distributed big-scale databases, they're not bad. An aircraft carrier is great if what you need to do is project US military hegemony in the South Pacific. But it's really, really crappy if you want to go get groceries at the shop, right? The two are not better or worse, they serve different needs. And the problem is, I will contend, that we didn't realize that this was all we had. And so we've been building bicycles out of aircraft carrier parts and then confused when it's hard to get to the shops. And to go a little further, I want to say to all of you here that if you feel like maybe these people here feel in the galley of the USS Nimitz, that aircraft carrier we saw before, where you don't have any agency or any authority. And in fact, if you serve on the Nimitz, you may not even see the sun for weeks at a time because they don't put a lot of portholes and windows into battleships, right? And so for many of us, and I have been there too, you feel like you are down in the hold of an aircraft carrier, serving, working, but never seeing the light of day. And this is an important distinction in technology, right? Ursula Franklin, who is a Canadian philosopher, described the difference between holistic and prescriptive technologies, where a holistic technology is one that empowers the user, right? Where it enables a craftsperson or an artisan to perform a task under their own direction, whereas a prescriptive technology places us under management, and that can be valuable, but it takes away our freedom. And she explored all of these ideas because she was a metallurgist who was fascinated by these thousands-year-old massive bronze cauldrons from China. And she realized that none of the people who were actually involved in making these things had agency over what they would be like, except the person who commissioned the work. And if you contrast that with pottery, right, a single artisan can create a beautiful piece under their own direction, right? And it's not that, again, one is better or worse. The whole reason she had this insight was her love of these pieces of art. But it's an important lens to think about how we all relate to this craft of software and the work that we do in it. And I think that when we build software, every community that we participate in is affected by software. There's not a discipline in the world that doesn't have an influence on software. I was looking for local examples, and here's Daniele Chiesa, a luthier, guitar maker here in Malaga. And Daniele uses modern CAD software to help build guitars, right? This hundreds-year-old craft, even still touched by software. And so I think that as we practice our craft in service of other people practicing their craft, we can take a moment to ask a question, which is, how are we exercising our skills to either produce technology that is more holistic or more prescriptive? And I'm going to close on that question. I don't have answers. It's not, again, that one is right or wrong, but it's that it's an axis of choice that I had never really considered until I started looking into this. And I want to leave you with that thought because, as Marshall McLuhan said, first we shape our tools, and thereafter they shape us. And since we are the ones who shape tools, then we have both an opportunity and a responsibility to think about how we shape them for everybody else. So we'll leave it there. Thanks for having me. I hope you've had a wonderful conference. I really enjoyed being here. And if you would like to know more about our work, you can find it in these places. And if you're really interested, we have a newsletter that goes out monthly-ish, and that's probably the easiest way to track us. So